Those who have seen wind turbines must be curious about. The wind turbine rotates so slowly, but can output electricity stably. How does it generate electricity? How many degrees of electricity can it generate per circle? This is the world's largest wind turbine. With a single power of 16 megawatts, it can power more than 30,000 households. Can you imagine how big it is? The generator is 152 meters above ground. Each blade is 123 meters long. The diameter of 3 blades is 260 meters. But when it works normally, it only rotates 10 to 20 times per minute. It rotates so slowly. How does it generate electricity? In fact, windmills are not completely pushed by the wind. It's not the wind's impact that really makes the blades rotate, but lift. The principle is the same as that of an airplane wing. When the wind blows over the blade, air flows through the upper and lower surfaces of the blade. Because the shape and angle of the blade are different, the airflow speed on the upper and lower sides is different. A pressure difference will be formed. Air always flows from high pressure areas to low pressure areas. This pressure difference creates an upward force, which is what we call lift. As long as the blade angle is appropriate, the stronger the wind, the faster the airflow, the greater the lift. The blade will be lifted and rotated forward, although the entire wind will seem to rotate slowly. But the outermost part of the blade is actually working, because the radius of the wind wheel is too large. The farther from the center, the higher the linear speed at the tip of the blade can easily exceed 200 kilometers per hour. The faster the speed, the greater the lift generated by the blade. This is the key reason why wind turbines can output huge power. But there is a problem. The greater the lift, the force the blade bears is terrifying. If these long blades are not controlled, will be torn apart. Therefore, large wind turbines have a very important variable pitch system, which can adjust the blade angle. When the wind is weak, the blade angle is larger. When the wind is strong, the blade angle automatically becomes smaller. To reduce lift, when encountering a storm, the blades can even swing along the wind, almost not rotating. If it needs to be stopped for maintenance, just adjust the blade angle to near 0 degrees. No matter how strong the wind is, the wind turbine will not rotate. Plus, the direction of the wind is not fixed. To ensure efficiency, the wind turbine must always face the wind. Therefore, there are wind speed and direction sensors on the top. Once the wind direction changes, the control system will drive the yaw motor. The entire nacelle slowly turns its head, so that the blades always face the wind direction. Next is the most crucial step. How to convert mechanical energy into electrical energy. We all know that the frequency of the power grid is fixed, while ordinary generators require high speed to reach this frequency, but the wind will only rotate 10 to 20 times per minute. It is definitely impossible to directly connect the generator, so the wind turbine must first amplify the speed. There is a gearbox in the nacelle, with a transmission ratio of 1 to 90. The blades turn slowly. The speed is amplified through multiple gears to increase the speed to 1000 to 1500 RPM. Only then can it enter the generator, the normal working speed range. Then it is sent to the generator to generate electricity. Meanwhile, there are 3 very important braking systems in the cabin. Mechanical brakes, used for emergencies or maintenance, which can completely stop the entire wind turbine. To maintain the braking system, before maintenance personnel go up, the blades must not rotate randomly. Electrical controlled brakes. When the speed is abnormal, the system will automatically intervene and control, so wind turbines don't rotate as they want, but a strictly controlled mechanical system. Now many new wind turbines have started to use permanent magnet synchronous generators and doubly fed induction generators. Through power electronic systems, convert unstable speed to stable, grid frequency reducing reliance on gearboxes, and more efficient. The electricity generated by the wind turbine is generally only a few thousand volts, but long-distance transmission requires high voltage and low loss. So there is a step-up transformer at the bottom of the fan to increase the voltage to 33 kilovolts, and then connect it to the grid, and then deliver to cities and households.